Okay, so let's look at these multiple choice questions I asked y'all to do today. So this is number 22 on the Berenstain. We have a piecewise function. They simply ask which of the following are true. First, the limit as x approaches 1. This one, I mean, you could lope it. Keep in mind that if you do choose to use L'Hopital's rule, you have to show numerator and denominator separately, which is just a lot of extra work. This one, I would prefer to just factor and cancel. X plus 1, x minus 1 over, my writing is garbage today, over x minus 1. The x minus 1's cancel. You can plug 1 into the remaining x plus 1, and you get an answer of 2. So yes, the limit does exist. They didn't ask you to show what the limit equals, but the limit does exist, and the limit is 2. So that is a true statement. Does f of 1 exist? And yes, it does, because right here, they tell you that f of 1 is equal to 4, so that is true. Is f continuous? And to show that 3 is true, for something to be continuous, your limit definition of continuity is limit as x approaches the points in question of your function must equal f of that value. And by looking at parts 1 and 2, we've already established the limit as x approaches 1 is 2. F of 1, they can tell you is 4. Those are not equal, therefore not continuous. And 1 and 2 are the only ones that are true for number 22. Number 23 is if f is continuous at 0, then k is equal to something. It's a similar problem to the last, except we need to find out what f of 0 is. And in order for something to be continuous, we need the limit as x approaches the point in question of f of x to equal f of 0. And f of 0 is the value of k. So really for this problem, if I can simply find this value right here, the limit as x approaches 0 of f of x, I will find f of 0, which is k, and that is the answer to the question. Do remember that if you are approaching 0, you're concerned about the left and right sides. And for this problem, the left and right of 0 would be any values not equal to, so we're going to use that top piece. So we're going to find the limit as x approaches 0 of this function, x squared minus x over 2x. There's my baby. And again, keep in mind that this year's AP exam is all free response. So you have to solve your limits in great detail. And while I could lope this one, remember L'Hopital's rule requires you to look at top and bottom individually to establish the indeterminate form. This one is just like number 22, where I feel it would be easier just to solve by factoring. On top, I can pull out an x. That leaves me x minus 1. On bottom, we don't have to do anything. The x's cancel. And when those divide out and cancel, I can plug 0 in. 0 minus 1 is negative 1, 2, and that is the value of f of 0, which is the value of k. So the answer for 23 is negative 1/2. So let's move on and look at number 24. And this one I had to grab the options because the options kind of tell me what to do. The question is asking about continuity at x equals 1, at x equals 2, and at x equals 0. Or is this function continuous everywhere? Really, the only points in question that I'm focusing on right now are 1 and 2, because that's where we have redefined points for f of 1 and f of 2. So let's talk about x equals 1 and 2 first. Okay, so on this one, let's look at x equals 1, and we need to determine if something's continuous that the limit is equal to f of 1. So for x equals 1, we're going to find the limit as x approaches 1 of f of x. So I need to be worried about the left and right, and that's going to be this top equation, because this top equation does represent 1, or f of x around 1. I think I'm going to go ahead and factor this up here. That factors to 3x, x minus 1 over, and the denominator factors x minus 1, x minus 2. And so we have 3x, x minus 1 over x minus 1, x minus 2. We can cancel the x minus 1s. And when I plug 1 into the remaining pieces, I have 3 times 1 over 3 minus 2. And so the limit does equal 3. And I'm double checking, make sure I didn't make a mistake, because f of 1 is equal to -3. This is not equal to f of 1, and therefore the function is not continuous at 1. Oh, this wording is terrible. So the function is continuous except at x equals 1, and so far that is true. E is definitely not true because we've already established that we are not continuous at 1, so E is out of the question. Now let's look at 2. And so now if x is equal to 2, we need to find the limit as x approaches 2. And so this one is interesting. I'm going to go ahead and use the reduced version, 3x over x minus 2. And if I try to plug in 2, I will get 6 divided by 0, which if you are divided by 0, this could be going to infinity, negative infinity, or if both sides are going in different directions, you would say D and E. I do not need to investigate this any further because I already know that f of 2 is equal to 4. So it doesn't matter which of those three conclusions I come to, this is not going to equal f of 2. Therefore, the function is not continuous at 2 also. And so we've now know that the function is discontinuous at 1 and 2. And so that rules out A and B because we need to have both of them. So C is good. Now I'm concerned about 0. They didn't tell me what f of 0 is, but x equals 0 would apply to this top function. So for x equals 0, for the limit, we'll do the limit as x approaches 0 of, and we can use the reduced version, 3x over x minus 2, and that would end up giving you 0. We also need to find f of 0. They did not provide it this time like they did with 1 and 2. And so f of 0, and here comes my daughter in the background, f of 0, nope, she stopped. Hang on just a second, sweetie. F of 0, I've lost my train of thought. Okay, it'd be 3 times 0, which is 0 in the numerator. My denominator would be 0 minus 0 plus 2, and that is 0. And so the limit does equal f of 0, which means that the function is continuous at x equals 0. And so D is not true, so we now know the answer is C. The function is continuous everywhere except 1 or 2. All right, number 27, same type question. We have a piecewise function in which the following are true. Does f of 0 exist? Does the limit exist? And is f continuous? And the answer to part 3 will be determined by our answers to options 1 and 2. And here comes my baby boy. Go. So f of 0 is 1. That's given, so that's true. Does the limit exist? Okay, so for option 2, limit as x approaches 0 of f of x. Now that's going to be around 0, so I'm not concerned about what's happening at 0. I'm going to use this top piece up here for the limit as x approaches 0, and just like the other ones, I could lope this, but it would be easier to solve this by factoring. So I'm going to remove the x, divide the x out of the top, which will then cancel with those x's, and you'll be left with 0 plus 1 for the answer after these x's are divided out. So I get that the limit as x approaches 0 does exist, and it equals 0, or I'm sorry, and it equals 1. Because f of 0 and f of 1 do exist, then the function is continuous. So all 3 are true for number 27. All right, so let's look at the 2011 question. So we are showing that the function is continuous. The question is not, is the function continuous? We know that the function is continuous. And to do that, we have to show through detail that the limit as x approaches 0 of f of x is equal to f of 0. And in these cases, the f of 0 or the f of whatever is typically the easier part. So I'm going to do f of 0 first. That's when x is equal to 0. So that's my top piece. And for x equals to 0, we have 1 minus 2 sine of 0, and sine of 0 is 0. So f of 0 is 1. Now for the limit, we do have to look at both left and right. And so to do that, in this case, the left side of 0 is the top part, and the right side of 0 is the bottom part. So I'm going to have to individually look at those two pieces, x approaches 0 from the left of f of x, is going to be 1 minus 2 times the sine of 0, which we just did, and we know that that is 1. Now I'm concerned about the right side. Limit as x approaches 0 from the right. And the right side of f of x is e to the negative 4x, so that will be e to the 0, which is also 1. And so with that, I can state that the limit as x approaches 0 of f of x is equal to 1, and that is also equal to f of 0. And because the limit as x approaches 0 is equal to f of 0, I know that f of x is continuous at x equals 0. So there's the 2011 problem. And then the final one, 2012 for C, we have this function f of x here. Now, this is probably irrelevant to this problem. Maybe it shows up in other parts, but you should recognize the square root of 25 minus x squared as a semicircle. Good old function semicircle there. Let's see, g is this function. And the question is g continuous at x equals negative 3? And so this is the same type of question. If something is continuous at negative 3, that means that the limit as x approaches negative 3 of f of x would equal f of negative 3. And this is g, not f, so I need to change those to g's. Pay attention to your functions. That would cost you a point on this question because f and g are both defined in this problem. So make sure that you are referencing the correct function. And I'm going to start with g of negative 3 because usually the g of or the f of question is easier than the limit question. And so g of negative 3, we equal negative 3 right here. And g of negative 3 would actually equal f of negative 3. And f of negative 3 is the square root of 25 minus negative 3 squared, which is 9. That ends up being the square root of 16, which is 4. So now that I know what g of negative 3 is, I need to find the limit as x approaches negative 3 of g. That is a terrible 3. And if you look at this function, you can hopefully already tell that the left and the right sides of g are represented by different equations. My left is the f equation. My right side of negative 3 is this bottom equation. And so I'm going to have to look at these individually. So let's look at the left side first. Limit as x approaches negative 3 from the left. That will be f of negative 3, which we've already established is 4. The limit as x approaches negative 3 from the right of g of x is going to be x plus 7. And so that'll be negative 3 plus 7, which is also equal to 4. And because left and right sides are the same, I know that the limit as x approaches negative 3 of g of x, my g's are, well, they're always screwed up, whatever, is equal to 4. And 4 was also the answer to g of negative 3. And because the limit as x approaches negative 3 of g is equal to g of negative 3, I can conclude that g is continuous at x equals negative 3. And so make sure you answer the question. Notice in the 2012 question, they actually asked, is g continuous? And so you actually need to make a statement declaring that g is or is not continuous. So I did that here. So if it's a yes or no question, maybe even a good idea is to write the word yes, therefore yes, because they did ask a yes or no question. Whereas in 2011, they told you to show that it is continuous. So you don't necessarily have to say, yes, the function is continuous. I think it's good practice. You can see that I did that. Oh, my boy's playing with an umbrella. You can see that I did write a conclusive statement that f is continuous. Probably not necessary because establishing that the limit is equal to f of whatever, that would have shown that f is